Hello, welcome to this webinar. My name is Rick Broers. I'm an SRE for Cloud Legends run by Kabisa. In this webinar, I'm going to give you some background on SLA, SLO, SLI, and SRE, and what does this all mean for you. If you're seeing this recording, which I've made 25th of May, it's good news for me because that means I've recently turned father, or I'm in the process of becoming one. And there'll be some colleagues in the chat assisting you with any questions, and you can still shoot me an email after. So without further ado, let's dive into it. What we'll be looking at today, we're going to do a quick introduction of Kabisa Cloud Legends. We're going to dive into the SRE principles, that's 6, and compare them a bit to what DevOps does. We're going to go over some terminology, among which the terms you've been seeing in this opening. And then we will be closing off with what SRE can mean for your enterprise or business. And there's room for some feedback questions. So, introduction, Cloud Legends by Kabisa. What do? We run cloud services. So think Kubernetes, think AWS, think Azure. All of those combined. We can help you setting up infrastructure as a code. We can do incident management for you. We have a specialized service for that. We can help you improve security or improve the cloud. And we can help you out with CI/CD, which is continuous integration, continuous deployment, which is also a part of SRE. So SRE, Site Reliability Engineering, tries to uphold 6 principles. The first of which, embrace risk. What does this mean? Systems nowadays, ecosystems are evolving every day. And there's not one single person which knows how the entire thing works. It's a given that parts will break within the system. So how do we deal with that? That's the embracing risk part. We're going to assume that things will break. We will not engineer for 100% uptime, as that is simply impossible. So there's 2 methods to deal with that. Well, reactively, that's incident management. And there's also a scientific proactive way, which is called chaos engineering. It's a rather new term. We won't be going into that for this session. But if you have questions regarding chaos engineering, feel free to hit us up. The next one, define SLOs, the bread and butter of SREs. It's the starting point into the site reliability engineering journey. It's positioned before SLAs, and we will see that in later slides. SREs will be trying to work on eliminating toil. So toil is a new term. It's comparable to operational tasks. And what it allows us to do is it allows us to keep innovating and not get swamped up in all kinds of operational tasks. More on that later in the presentation. We will be trying to monitor distributed systems. So as I said in the embrace risk part, systems nowadays are complex, and we need a way to gain observability in those systems. We have to avoid an overload of notifications. What do we monitor? How do we observe the system? We're going to embrace release engineering. This is, you can also see as we automate what we can in the process. Also, one of the principles of DevOps. And the last one, but also a very important one, is keep it simple. All of the things above, we're not going to try to over-engineer these. We're going to try to keep them as simple as possible so we can explain them and understand them. Together with DevOps, class SRE implements DevOps. So what does this mean? When you look for SRE on the internet, you will always find a comparison towards DevOps. So it's unavoidable for me to also give some attention to it. So one of the first principle actually of DevOps is customer first thinking. SRE doesn't have that as a principle, as we've seen in the previous slide, but SRE simply upholds this as true. So we're always going to think from a principle, customer first perspective. What we also both try to do is to break down the barriers between teams. So the picture we see in my background is what we call the wall of confusion. It's when developers who want speed are throwing over features into probably the pipeline, and operators who have to keep their systems stable and deal with the possible instability from all of these developers' new features. We're going to see some mechanisms on how we can get these two teams to get talking to each other and make this whole process data-driven. So what are we going to handle today? The words here. So we're going to start with an SLA. Then we're going to get to how we can build up an SLO, which is via an SLE. The negative part of an SLO, what remains, is the error budget. So these three together make the data-driven part. Then there's 4 terms left. The risk policy, it's what happens when we break the error budget. We're going to see what toil actually means, as I've explained in the principles. We're going to go over observability, also mentioned shortly during the monitor distributed systems part. And we're going to see what incident management means within SRE. So, SLA, we all know it. When an SLA is hit, your customers or we look like the cat on the right. Not happy. And well, SLAs, we have been working with them as so a state service level agreement. What are we going to agree upon that the service should uphold to? And most of the times when the SLA is hit, there's a penalty involved. Cost, rebate, discounts. It doesn't matter. It's at least it's most of the times it's something bad. So with the SLO, we are trying to position it in front of it. We're going to try to make it a metric where which the customer is still happy, and if it is broken, he's also still happy, but we have to be careful that we're not going to hit the SLA as indicated in the picture. So how do we get to an SLO? Well, via an SLI, so a service level indicator. An indicator that's going to tell us how a certain service is performing right now. And we're going to do that based on some golden signals. So we're not going to be looking at some CPU or well, we could actually be looking at network traffic. So what are those golden signals? Those golden signals are latency, traffic, the error rate, and saturation of certain. So we're going to look into a bad example first and then into a good example based on the error rate. So a bad example. Number of successful web requests on the server. It's actually something that you sometimes see in dashboarding or metric tooling, as in, okay, this is the amount of happy requests we are doing. But what is it actually telling us apart from how many good requests there are? Nothing much. So how can we improve upon this and make it a valid SLI? Well, let me show you. First, we're going to add a proportion. So we're going to, you see the first word, proportion of GET requests. And then you see in the second sentence divided by all the HTTP GET requests. So in the first HTTP GET request that have a successful 2xx response code, status code actually, put off against all of the HTTP GET requests. There's a certain thing, a couple of things I want you to notice here. It's the what, the HTTP GET requests from a certain service, the service ID content. That's basically the who. Where are we going to measure it? We're going to measure it at the load balancer. And how are we going to measure it? Well, it's a proportion of the successful ones, the 2xx versus all of the others. There can be much more nuance in this. For example, maybe you want to skip 5xx codes or certain other codes. But for the example, this is perfect. So how do we turn this SLI into an SLO? Well, first we have to start plotting this SLI, measure it, and start plotting it. A service level objective, SLO. It's an agreement on the SLIs for a period of time, and with it we can possibly determine the quality of the service we are providing. So take previous slide SLI expressed in green here. Over a 4-week period for 24/7, the web request status to XX proportion should be higher than 99.99%. What this allows us to do is to start plotting a graph, of which I do not have an example. Maybe I should edit that in by some magic. And with this number, you can start measuring when you can see when you're above it, when you're below it, and it gives you a certain rate. And this rate is expressed by the error budget. The error budget is 100% minus the SLO. So if we put that in an example, so we have previous slides, SLO, 99.99%. Let's assume this service handles 3 million requests in a month. We've stated 99.99%. This leaves us 0.01% of requests that may result in errors without breaking our SLO. So what you'll see is that the amount of errors that you can make changes on the amount of requests that you handle. So it's a sliding scale, and that means it slides along with your service growth. On 3 million requests with this error, with these amounts, we can only have 300 requests that may result in an error, which is not much, but we should be aiming for spending this budget. And why that is to not put wrong assumptions to the client. And when we hit this error budget, when we've hit the SLO, we should still not be hitting the SLA, as we've seen in the SLA example. What this allows us to do is if the error budget is not yet spent in a certain amount of time, we can, for example, put some more risky releases out, or we can, or if we are spending the budget every time and time again, it might mean that we have to look into solving some technical debt. So this, you see, is where one of the first things comes in for solving the wall of confusion, solving the understanding between the dev and ops teams. So what happens when this error budget is broken? That's where the risk policy, or also called the error budget policy, comes in. So what we do when the error budget is exceeded? Well, what you see a lot, but these aren't any static rules. What you see a lot of times is that you stop the automated delivery of features, stop CI/CD, and start cherry picking releases, start cherry picking commits. Start only allow commits which improve the reliability of your product. If you keep breaking the SLO time and time again, it's probably time to see if your SLOs are maybe too tight, or the numbers are not entirely in the right scope. And as I've said on the previous slide, it's a perfect tool for getting this technical debt in. So what you could decide with your team is, okay, the error budget is hit. We have to see some of these technical debt issues if they improve the error budget. So some takeaways from this, which I want you to understand. It's that with an SLO, we can build the right stuff and measure and improve what is important. Um, so they are most powerful when they're designed when they're designed around system capabilities. And SLOs should tie back to business objectives. Okay, so to give you a short example of this, imagine it's your business objective to get new users on your platform. So as an SLI would be a valid SLI and SLO for that would be to look if the registration process is able to continue without faults and um, response within certain amounts that you state. You want it to be snappy and responsive. So an SLI upon latency would be very valid here. It's all about finding a balance between innovation and reliability. So those were basically the data-driven parts of the SRE. So with the Aero budget and the SLO, you can get some tools to have conversations between your dev and ops teams or between other parts of your business and start measuring things and get the conversation going before the SLA hits. So toil, I've mentioned it before. A new term for operational work. Toil is the kind of work tied to running a production service that tends to be manual, repetitive, automatable, tactical, and most of the times what you see with this operation work is that it scales linearly as your service also grows. As an SRE, we try to, well, firstly, we try to be aware and measure the amount of toil we are running into, and we try to keep the amount of toil beneath 50%. Why is this? This is to keep a healthy culture and a healthy working balance, and that there's also the other 50% or the multiple of it should be spent on engineering work. So engineering work in this case is innovation, is the tomorrow's business. Some toil is unavoidable, such as, for example, and also not necessarily something you should automate away. It would be hard to automate away, for example, a meeting or the training of juniors, which is in the long run it's valuable work, but it's still considered toil. Observability. So observability, it's the next step of monitoring basically. It consists of 3 pillars. The pillars being metrics, logs, and traces. So metrics is telemetry, time series data of what your application, CPU, or whatever kind of ticker is doing. Logs is most of the times a user traversing your platform, following it, and traces is one run of code, for example, a serverless function. And the difference between observability and monitoring is that monitoring tells you whether a system is working, and observability should also be able to answer the question why it isn't working. And observability, we try also to have valuable signals together with these SLOs. So we mainly want to be alerted when the SLOs are getting endangered of being hit. And we're going to be really sensible of which notifications we are letting through and which ones are not of any value. So we want low noise, high signal for our monitoring or observability. And this is a really nice fit. This drawing you see on the screen, it's a really nice fit also with the Kabisa values, which is actually kind of the same. You see them on the right. Um, just a funny observation I did. Incident management, another term that SRE um, has some solutions or propositions for. First, let's state that any SRE should have problem-solving skills, and so we can do some effective problem resolving. Um, basic skills, basic troubleshooting skills are essential to have, but it's also very valuable to have some background or insight on the platform that we are working on. In an incident, we will always be trying to do mitigation first. So the customer first principle, we want to get the service back in working order before looking into what exactly is going wrong. So that it is together with the effective problem resolving. Procedures, being on call is heavy. Why is that in there? That's basically to give the colleagues, developers who are working on the problems some grip on the systems. They know what they need to do in certain situations. They're not swimming in the dark. And as a RE, we will try to signal where procedures are missing, where procedures could be improved, and helping colleagues. This comes together with the blameless culture and the psychological safety. So SRE tries to create a blameless culture in which people can share what happened, what led up to the incident, without fear for job safety or any kind of punitive repercussions. So that we can get to the bottom of the issue and mitigate it as soon as possible without pointing fingers at anyone. And how can we learn from incidents? That's via the postmortems. So postmortems are our learning tools. During an incident, it's basically a living document on which we will keep a timeline of what is happening, what we are trying, what kind of mitigations. And there will also, in the end, there will also be some actionable points in a postmortem or an incident report on what to improve and follow up on them. And if done correctly, postmortems can be very valuable and will allow you to improve on every incident that happens, and hopefully also avoid the same incident from happening twice. So what can SRE do for your enterprise in the short term? Well, the first step for anyone interested to getting started with SRE would be to start creating SLOs, service level objectives, and withholding the together with SLIs. Another approach would be to look into the incident management. Is there many recurring issues? Maybe the post-mortem method can help. Maybe there's not enough psychological safety. And that could be an area of attention. Maybe the wall of confusion is very strong. Developers not understanding why their features not are getting through, while the operators are scrambling to keep all of it stable. Or maybe engineers are drowning in toil, are doing mainly all kinds of firefighting tasks and all kinds of I'm mainly working on firefighting tasks, and you want to get them working on engineering work as well. If you're experiencing any of these issues, well, be sure to contact Cloud Legends, and well, maybe I can help you out. So that was it. We've come to the end of the webinar. As I've said in the beginning, this is a recording, and any questions to me, you can send via the QR code. You will find my email address. If you have any questions right now, my colleagues will answer them happily for you. If there's anything you would like to go deeper into, or you want to have a session that goes deeper into some of the subject I've touched, maybe an SLO workshop on how to set up SLOs, or you want to know more about chaos engineering, please let me know. Thank you very much. And I'll now leave some time for questions.